When it comes to time series forecasting and analysis in general, one of the first forecasting technique that you are going to be introduced to is the concept of the moving average. Not only is this a very simple concept, but it is also a very powerful concept that allows you to see trends of a time series data in the long run. There is a reason why the moving average is very useful in the stock market, because by using the concept of the moving average, you can be able to see trends within a short period of time, and you can also be able to see trends over a long period of time. So the moving average is something, a concept and time series analysis that we don't joke with, and that is what we would be talking about today, because in this video we are going to be talking about the concept of the moving average, everything you need to know about moving average, how it is being used, how it is being calculated, among other details that defines this beautiful concept. And to end it all, I'll be using Microsoft Excel to teach you how to calculate moving average on your time series data. So without further ado, let's get into the video and start learning properly. I'm sure the first question you're going to be asking yourself is, what is moving average? And to be honest with you, the answer to your question basically lies in those two words: moving average. An average that is moving. It simply means that we use average to smoothen out our data in the long run. I want you to know that the moving average can be seen as a forecasting model, but most times, or larger chunk of the times, it is more of a smoothing model. By smoothing model, it simply means that we use it to remove the noise that we have in our data set, so that in the long run we are able to see the clearer pattern that is within this data set. And like I said earlier on, the moving average does this by using the simple average, that is the arithmetic mean. We basically have two types of moving average. We have what we call the simple arithmetic moving average, where we use the basic mean, that is the summation x divided by n, to get the average and let it move in the long run. And we have the exponential moving average, which is more or less like a weighted version of the simple mean moving average. But our attention today is going to be focused on the simple mean, or the arithmetic mean moving average. And when it comes to this moving average, we are going to be using the value of mean to smoothen out the data so that we can be able to see the trend in the long run. One of the properties of a time series data is that your data set is collected over a time period. That is, we can collect our data either monthly, daily, weekly, or yearly. The way you collect your data over a time period is going to determine the type of moving average, in quotes, that you're going to be performing. Let's say you are working in the stock market, where data set about price or sales is collected daily. We have day 1, we have day 2, we have day 3, we have day 4, down to like day 50 or something. The moving average that you're going to be working with in this context is going to be a daily moving average. So you can ask questions like, oh, what is the 20 days moving average? What is the 5 days moving average? What is the 10 days moving average? What is the 50 days moving average? And if you are working in probably a store and they are getting their data set monthly, so we have data for month 1, month 2, month 3, or profits that was collected over the month, they can now start asking questions like, so what is the 5 months moving average? What is the 3 months moving average? What is the 6 months moving average? And stuff like that. Now, one thing I want us to know is based on the fact that the longer the days of your moving average, the more smoothened out your forecast or your trend is going to be in the long run. So in the stock market, 100 moving average is going to be more smoothened out and clearer to see the trend compared to a 10 days or a 5 days moving average. So this is why when it gets to the stock market, we usually use a very long moving average, as long as 200 days moving average, because we have a whole lot of data that has been collected. Now that I've explained the basics of the moving average to you, let's try to understand the moving average from the mathematical standpoint. So this right here is a very basic simple time series data. Okay, we are collecting the price of a variable of a commodity over a 10 days period, and we are interested in calculating the 3 days moving average. So that means we are going to be starting our average from the 3rd day. So that means from this day right here. So that's it. So we have to calculate the average at the 3rd day, and that's going to be 23 plus 32 plus 33 divided by 3. And when we do the math, we have our answer to be 27.5. So the first moving average, which happens to be on the 3rd day, is 27.5. 0.5. Okay, so we come to the next moving average, which is the average from the fourth day, and this time our average has moved from 23, 32, 33 down to 32, 33 and 34. You can see that the average has moved, so we need to get the average of 32, 33 and 34. Okay, so the average, the second moving average, which is the average at the fourth day, is going to be 32 plus 33 plus 34 divided by 2, and that gives us 32.5. And the next is for us to get the third moving average, which is the moving average at the fifth day. And at this point in time, we are going to be working with 33, 34 and 45. So that means the average of 33, 34 and 35. So that's going to be 33 plus 34 plus 35 divided by 2, divided by 3 rather. When we do the math, we have our answer to be equals to 33.5, and we keep doing it like that till we get to the last moving average, which gives us a value of 39. Now you can see that the moving average is actually very simple. All you have to do is to just get the average, and then you move down the time series as time goes on. Now, using your hand to do this can be a bit tedious and stressful, and also prone to a lot of errors, and that is why we have softwares that can help us to calculate the moving average, either a 3 days moving average, a 5 days moving average, or any type of moving average that we need to calculate. And I'll be moving into Microsoft Excel to teach us how to calculate moving average and also the error metrics that can be attached to the moving average. So let's get into it. So basically, there are actually two ways in which you can perform or get the moving average that is attached to your time series data, and I'll be talking about those two methods today. So the first method is to use the data analysis toolpack, and the second method is you using Excel functions, and the both of them work quite fine. I'll be starting with the data analysis toolpack. So you come to data, and then you come to data analysis, and you locate moving average. So I think moving average is right here, and once you click on moving average, you click on OK. It brings out this dialog and asks for the input range. So the input range is where you are going to be dropping the variable that is changing with time. And in this case of ours, our variable that is changing with time is price. That is our input range is time. Okay, so I'm going to like click on this arrow, then drag all of this down. If I'm going to be selecting the labels, so that's from price down here, I will be clicking on labels in first row to let Excel know that I am including the labels in the first row, but I don't want to, so I just erase this and just select from here down to here. Okay, now the next thing is that it asks for the interval. So it's asking you, do you want to make like a 2 days interval, 3 days interval, meaning a 3 days moving average, a 2 days moving average, a 4 days moving average, a 5 days moving average? So earlier on we did a 3 days moving average. So let's do 3. Okay, so we just put 3 right here, and it asks for the output range. So where do you want to paste your result? And you know, definitely I want to like paste it here. Yeah, so yeah, it's better. Then I click on OK, and as you can see, okay, I can just edit this and say 3 days moving average. All right, so if you notice, the first 2 days didn't give us any values. Okay, and that is okay, that's fine. So this is the 3 days moving average. Okay, and we can also do like a 5 days moving average. You know, the same thing. All we have to do is to change that, and let's say, okay, let's say this is 5 days right here. So let's say 5 days. Let's make it 5 days moving average. Okay, so we come back to data analysis rather, moving average. Then our input range is still the same thing, so we can just change this to 5, and then the output range, we erase this and we select this. Okay, and we click on OK. As you can see, the first 4 days are not having any value, and that is this. So I mentioned something about the fact that when it comes to moving average, that the longer the moving average, or the longer the time period of your moving average, the better the model is, or the smoother the forecast is. So I would like to visualize this by using a line chart so that you can see. So first thing first, if I get the line chart for price over the days. Okay, just this. All right, I insert a line chart. So okay, let me just use a line chart. So this is right here. So this is price versus day, right? Now I can decide that I want to like plot a line chart for the days, the price rather, and sorry, the days and the 3 days moving average. So I can just select this. Excuse me. I can select this, deselect this, insert. So look at that of the 3 days moving average. You can see that the forecast or the trend rather for the normal day is a bit noisy. It's not as smooth as when you compare to this. Okay, now let's do for the 5 days and let's see if we get something smoother than the one we have on the 3 days average at the 3 days moving average. Okay, so we can also, you know, select this and this, insert, and here we go. And you can see that the one of the 5 days is a bit smoother compared to the one of the 3 days, although this is getting shorter now. And that's just one way we can actually, okay, let me just move all of this right here out to this place. Okay, we can actually calculate the moving average. Now we can also calculate the moving average by using your basic Excel function. Okay, so you don't need to like use the data analytics toolbar. Let me take all of this, excuse me, give me a second, let me take all of this somewhere else so that we'll just have enough space with us. Okay, all right, so let's copy days and price. Let's copy right here and just drop it right here. All right, so we want to get the 3 days moving average. So 3 days moving average. Okay, all right, so like I said, it's just average, so you need to start from the 3rd day. You are going to be starting from the 3rd day, so and that's going to be the average. Then we select from here down to here. We click, oh excuse me, yes, average. All right, so we select from here down to here and we click on enter, and you see it gives us the moving average for the first moving average, which is for the 3rd day. Then we can drag this down and you see we find ourselves with the moving average for 3 days. As simple as that. Now we can also do the same thing for the 5 days, you know, and stuff like that. Now I'll still come back to the 5 days, okay, and I would like to mention the error metrics that we use for our moving average. So we have like I think 5 error metrics. We have what we call the mean error or the mean deviation. We have the mean absolute error or the mean absolute deviation. We have the mean square error. We have the root mean square error, and then we also have the mean absolute percentage error. So let's get the mean deviation or the mean error. Now the error is simply the difference between your average, your averaging value and the actual price. So your error right here. So let's get the error. So the error is equals to the difference between the value you got based on your moving average and then the actual value. So that's going to be equals to, that's this minus this. Okay, so then you drag this down. Then the average of this value is going to give us the mean error, or we can say the mean deviation, because your error is the same thing as your deviation. So we get the average of this, and then excuse me, let's do that again. All right, so we take this down and we click on enter. So that means the mean error or the mean deviation for this data set of ours for this 3 days moving average is minus 0.6667. So we also need to get the mean absolute error or the mean absolute deviation. So right here we have to get the absolute error. And to get the absolute error, all we have to do is to use the ABS function, which represents absolutes, and we take all of this down here and that, and then we bring it down here. So that is that we've gotten the absolute. Now the absolute is just any positive number remains positive and any negative number is going to become positive. So let's get the average of this. So we use the average function. and select this, and that is it. So our mean absolute error, or the mean absolute deviation, is actually equals to 3. So the next is for us to calculate the value of the mean square error. So for the mean square error, we need to get the square of the error, then get the average. So we have the square of error. Okay, so the square of error, it simply means you should square your error. So that's going to be equals to, then we'll square this, okay, raised to the power of 2. So we have that, then we drag this down. So this right here is the square of error. Then the mean square error is going to be so that's going to be average of everything right here, and we click on enter. Okay, excuse me, for some red reasons I don't know why this is not really going fine. And our mean square error, our mean square error, yes, that is MSE, is 14.194. You know what, let me just write something here. So that's so this is a mean deviation, or the mean error. This is a mean absolute deviation. This right here is the mean square error. Okay, now let me just make this cell bold. I need to make it bold. Okay, so our mean square error is 14.194. Our mean absolute deviation is 3. Our mean deviation is minus 0.667. Now the next thing we have to get is the mean absolute percentage error. So in this case, we have to get the percentage error first. So the percentage, so just say percentage error. Okay, so the percentage error is simply your error, okay, divided by the actual value times 100. So we have to say, let's bring the bracket in right here. So that's this divided by the actual value, which is 33, then times 100, and you click on enter. Okay, so this is the percentage error. I can convert this to percentage if I want to, but yeah, we can. Okay, let's just, and then, okay, you know what, maybe just make it general. Yeah, so let's just take it down here. Okay, and then this is the percentage error. Now we need the absolute, so we need absolute percentage error. Okay, yeah, it's very needed. So that means we get the absolute value, that's ABS, and then we drag all of this down. Okay, and then, oh, excuse me, I think I made a mistake, sorry, let's do that again. So ABS, all right, so of this number exactly, then we bring this down. Yeah, yeah, so this is this. So the next is for us to calculate. Can I drag this down? Okay, I know it's coming down here exactly. Yeah, so the next is for us to calculate the mean absolute percentage error. So that's gonna be equals to average, you know, then we select all of this, and that, so this is the mean absolute percentage error. And the last one is what we'll call the root mean square error. Now the root mean square error is the square root of the mean square error exactly. Yeah, so for our Rmse, that is the root mean square, we can just say we have to like square root, so sqrt, we get the square root of the mean square error, which is 14.194, and then click on enter. So in this case, our root mean square error is 3.76755. Now this may not make sense to you until you compare it to another moving average. So what I'm going to do is to compare the error metrics of this data to that of a 5 days moving average. So what I'm going to do is right here, I'll just select this data, everything we have right here, I copy it, then I paste it here. Okay, now I want to get the 5 days moving average. Okay, so that means I'm going to be deleting this, I delete this. Okay, now because for a 5 days moving average, we are going to be starting from the 5th day, so I delete this also. It's like equals to, the average. All right, and then I select everything from here down to here. So that's 33.4. As you can see, the same value right here, and then I drag all of this down. And once I drag it down, you see that the formula changes. Okay, everything changes. So we can just change this to 5 days moving average, and just like that, we've been able to calculate the error, the mean absolute error, the mean square error, the mean absolute percentage error for the 5 days moving average and the 3 days moving average. When you take a closer look at the 3 days moving average and the 5 days moving average, you're going to realize that the 3 days moving average, when it comes to error metrics, is having less errors compared to that of the 5 days moving average, as you can see. So the mean deviation right here is lower compared to the one here. The MAD right here is 3, the MAD right there is 12.45. The same thing with MSE and the Rmse and all of those stuff. So in this case of ours, the 3 days moving average is having less errors compared to that of the 5 days moving average. If you enjoyed this video and you also learned something new from this video, please don't hesitate to give this video a thumbs up and also subscribe to this YouTube channel. Do you feel like I missed something or you have some questions for me? Please don't hesitate to go down to the comment section and drop your questions. I would be willing and be ready to attend to all of them. Thanks for making it to the end of this video. Do you want to know about time series data and time series analysis in general? I have a video right here that I'll be linking for you that can help you out. You can check that out. Or do you want to know how to analyze a data set properly? I also have a video right here that can help you out. Thanks for making it to the end of this video once again, and we'll see you in the next one. Bye for now.